Our final presentation this afternoon addresses the crucial role of mechanical insulation plays in reducing energy consumption and lowering operations costs on capital projects. Presenting are Pete, I'm going to probably butcher this, Elmini, and James Petrides of Heat and Frost Insulators, LMCT. Their full bios and slides are available in the app. Please help welcome them to the stage.
Good afternoon, folks. My name is Pete Ilomini. The gentleman didn't do too bad with my name. It's a difficult name. It took me 12 years to figure it out when I was growing up. But thank you for being in the room and listening to what we have to say. This is my partner in crime, Jim Petrides. And we're going to be talking to you about something that hopefully you'll be enlightened with, and that's mechanical insulation. And one of the reasons why we're even at this conference is to be able to enlighten you about our very specialized craft of mechanical insulation and the amount of money and the amount of energy that you can save. Now, you go out into the street, you can ask anybody what an electrician does, they got a good idea. Carpenter, plumber, roofer, painter. You ask them what an insulator does, you get a glazed look in their eyes. And it's not just the general public. That also goes for engineers, architects, and even many of you users. And all we want to be able to do is educate you on the awareness of our specialized craft. In a couple of moments, I'm going to turn it over to Jim, and he's going to take you through hopefully some surprising facts that are going to enlighten you. But before I do, I want to take a moment to share something with you that was very personal to me. 6 years ago, I attended the CURT conference. My organizations, we've been coming here for quite a long time, but it was my first time 6 years ago. I've been here ever since, every year. And there was a session that was on the docket. I was at my booth doing the same thing I'm doing now, and it was about a subject matter of preventing suicide in construction. Taboo subject, especially even as of 6 years ago. And I contemplated, is that something I should go to or not? And I ended up doing it. And it became a religious experience for me. I have spent most of my professional career teaching construction safety and health. And I was unaware of the fact that 5 times construction workers are dying from suicide more than they are of construction accidents. That blew my mind. I didn't know how we were missing it with all of the effort and the money we spend into our training programs, why we were not talking about it. And for the last 6 years, I made it my personal crusade to talk about it at every level that I can get to in our construction field. And I just want to thank you to CURT, Mr. Sizemore, Cal Beyer, for putting on that session 6 years ago. It has made a difference with us, the insulators, as well as the other members within the building trades. So thank you, CURT, for doing that. But with no further time, I know we're tight on schedule, and we're the last one today. I'd like to introduce Jim Petrides. There is no one in the country that has performed more mechanical insulation energy audits than Jim. And when it comes to mechanical insulation, by far, he is one of the premier experts in this country. Jim?
Thank you. Thank you for being here. As Pete said, I'm Jim Petrides. Do we have the slides up on here from the slideshow? Yes, no, maybe? Because part of that's going to have to do with what we're trying to discuss. So hopefully we do. Okay, so this is Pete, myself. Next slide, please. So I'm going to start out with what mechanical insulation is. So many people know what it is, many people don't know what mechanical insulation is. As you can see from the slide, mechanical insulation are different products that are installed to reduce the flow of energy away from mechanical systems. So, to me, a picture's worth 1,000 words. Here are some examples of different facilities, different types of mechanical insulation. These have jackets on them. These have sometimes what's called an all-service jacket or a PVC jacket. Underneath that are different types of materials. As we go through this, I just want to make sure you understand we're not a company, so we're not selling anything in terms of a particular company or brand. We're not selling a material. We're trying to simply educate you as to what mechanical insulation is. Oftentimes, we are thought of as a commodity, and improperly installed products cause a litany of issues on job sites. They cause issues in our school systems, they cause issues in our hospitals, they cause issues on our commercial products, and they make us less competitive in the marketplace. And so our goal is to go through that and talk about what we can do and what mechanical insulation is. I hit the button the wrong way. So, how do I go back? Oh, there it is, sorry. Let's go to the next one. So here's some different examples of mechanical insulation. You may see this outside buildings. This building has a significant amount of mechanical insulation in it. If it had a good amount of proper building envelope insulation and door sweeps, it wouldn't have been 30 degrees in here this week. So that's what the effect that insulation can have. We don't insulate building envelopes. We don't insulate the exteriors or the ceilings or the roofs. We insulate the mechanical systems, and that includes the piping, the ductwork, and the equipment on those systems. So here's some different examples in different locations. Mechanical insulation plays an important part, and it's a system. It's not a particular product. A lot of times people think we're a commodity, but we're not a commodity. We are a product and a system, and the entire system has to be installed properly. Unfortunately, if you go into a building, any building, and the electric isn't installed properly, and the lights don't work, everybody knows it. If the plumbing's not installed, and you don't have running water, or the restrooms don't work, everybody knows it. If you don't install mechanical insulation, the building will still work. The building will still function. The system will still function. What won't happen is that there will be a significant loss of energy on that system, and the owner will pay for that time and time again. So for the products that we install, we have significant savings in a facility. Here's an example of, on the right-hand side, these are side-by-side images. So on the left is an image of some piping. On the right is an infrared image of the same piping. So we're simply trying to show the delta T, the temperature differential between those. And in this particular case, we're looking at lighting. The electricians have done a great job of selling lighting retrofits. Everybody, when you talk about what do we need to do to save energy, well, we should start with our lights. But when it comes to mechanical insulation, 1 foot of insulation on a 350-degree line saves approximately 16 times the amount of energy that lighting retrofit changes. So our paybacks are phenomenal, and people don't realize that because we've been around for 150 years. Mechanical insulation started out with different products. At one point, we used a ton of asbestos. We used a lot of other products. Been around forever. So we're not thought about as what we can do for a system. Here's a typical mechanical system and the different pieces of the mechanical system, and we insulate most of the parts of those systems. Our job as a mechanical insulator is to insulate the HVAC, the plumbing systems, the process systems, the piping, the ductwork. Those are the things that we insulate on most projects. The benefits of mechanical insulation are tremendous, and we'll talk about those in a minute. So here we're talking about the benefits of mechanical insulation and where they're used. So they're used in manufacturing facilities, they're used in daycare facilities, healthcare, hospitals, hotels. Any commercial building has some mechanical insulation in it somewhere, or at least it should. Every manufacturing facility usually has significant amounts of mechanical insulation. If you want a process to work, if you're in a refinery and you want that refinery to process the oil efficiently into different products, the better those systems are insulated, the quicker and the cheaper they can secure those processes and improve that. So these are some of the different facilities and where we're going to see mechanical insulation. Here's an example of mechanical insulation that's neglected. So just a picture that was taken, and these are all over the country. We go in different facilities everywhere, and you're going to see different places where mechanical insulation issues, where insulation is missing, where it's been specified and installed improperly, where it's treated as a commodity and we didn't have professionals installing it, so you have gaps in the system. You end up with mold and corrosion and moisture under the insulation, all those different types of things. Mechanical insulation, if it's installed properly, it can function for 30, 40 years, unless it's abused. If you look around the country, if you look in Texas, if you look in Florida, if you look in Ohio, Indiana, California, Minnesota, New York, all of those states have shut down schools because they had mold issues in the schools. So we don't talk about the cost of that improperly installed insulation that ended up with mold caused from condensation in the school systems. That's simply one of the issues. Indoor air quality can be affected. In hospitals, for example, a recent study was done by the American Pharmacological Society, and that study showed that in the hospitals in the United States alone, 2 million individuals end up with secondary infections. Those are infections they didn't have when they went into the hospital. So I'm going to the hospital, I've got a busted leg, busted knee, ankle, whatever it is, and I end up with another infection that I didn't have when I went in. Of those 2 million people that get those infections, of those 2 million people, over 200,000 people die of those secondary infections. 200,000 people die in our country because we have indoor air quality issues, because people are getting secondary infections. Now, some are caused by SARS, some are caused by respiratory issues, but some of them are caused by improperly installed insulation. And when insulation is improperly installed and you get condensation, you end up with water issues, you end up with mold growth. When mold spores, you end up with mycotoxins from those spores, and those mycotoxins then are considered a secondary infection. The cost per patient per hospital is right around $8,500 per patient. So that's an issue that we don't talk about. You know, the hospitals know about it. They're not going to tell you that if I come in the hospital, you're likely to get another infection that you didn't have when you went in, and we're not going to tell you that that's our fault, and we certainly don't want to be liable for that. But it is a significant issue in these different facilities. Mechanical insulation. You think about mechanical insulation, you think about electrical. You have to have a licensed electrician on the job site. A master electrician has to be on the job site and has a license because they have to know what the codes are, what the specifications are. They have to understand how that system works. In plumbing, for the same reason, we have regulations where you have to have a licensed plumber on a project, depending on the size and the scope. In mechanical insulation, there is no code, specification, national regulation, energy efficiency code for mechanical insulation. It does not exist. Therefore, a lot of times when a contract is bid to install a building, in generalities, if we're going to spend $100 million on a job, then the HVAC system typically is about 10% of that, so it's about $10 million. The mechanical insulation is typically 10% of that, which is about $1 million. So on a $100 million project, mechanical insulation is 1%. So we're often not the big picture in the room, so we can get value engineered out, and that becomes an issue. Mechanical insulation is often overlooked. If you're in a mechanical room, if you're in a particular facility, I walked through the halls back in this facility, in this hotel. When a valve leaks, when a packing nut starts leaking, when a gasket needs changed, they'll remove the insulation, They'll fix the mechanical issue, but they usually do not reinstall the insulation. And from that point on, the system has been compromised and does not function as designed. Because it then doesn't function as designed, then you have a loss of energy, and then you have oftentimes, depending on the condition, the temperatures, you'll have moisture infiltration. Many different mechanical insulation products are open cell or open wicking. We'll go through that product, and you end up with a compromised system where the efficiency of the insulation system doesn't work at all. And we don't realize that. We don't realize the energy loss from that. Here in America, and since I can't see the slides, I got to step over here. Oftentimes, when the project is bid, we're value engineered out, and we're value engineered out because the plumber, the mechanical contractor on that system, if he has working for a general contractor, they usually limit the amount of profit he can make or markup he can have on mechanical installation or a subcontractor to 10%. Because that's limited to 10%, he knows what that cost is and he knows what it's going to be. If he value engineers that out, he's value engineering out only 10% that he can make on that project, typically. If it's his project, if he's the mechanical installer for the piping, if he's installing the ductwork, usually he can do better than that 10% and he has control of that. So he's much more likely to value engineer out mechanical insulation on the project because it's not going to be his high revenue product on that project. And that's something that we often don't think about and don't realize when a project's being bid and when a project's being designed and built. We also have to worry about the different improperly installed systems throughout the U.S. Oftentimes, a product will be designed, it'll call for 2 inches, 3 inches, 4 inches of product on a job. Most things are checked and most things are reviewed and inspected. Very few inspectors understand what mechanical insulation is. Many of them don't know where to look. Many of them don't know what to look for. And oftentimes, a plumber will put in piping on a job. It's cheaper for him to put on a smaller hanger, and therefore there's not room for mechanical insulation. And if the insulation is a subcontractor to him, that's going to put on a less thick insulation product that doesn't meet specifications because it's saving him money both on the hangers and it's saving the subcontractor money so they comply. So there is a significant amount of improperly installed product in the U.S. How is mechanical insulation compromised? Well, it's compromised by people using insulation as step ladders. I've been on projects, I've been in tunnels underground where the maintenance guys would go down the hallway and you knew where they had built their nest, so to speak, because they took the insulation or reduced the insulation on the warm hot water heating lines. They had blankets in there. They made sure the light bulbs didn't work in that particular section so no one knew they were in there, and that's where they went and slept during the day. That's where they compromised their work schedule. That's where they rested, all those kind of things. So insulation is compromised by people stepping on it, by people sleeping on it, by equipment running into it, by being removed for valves, gaskets, flanges, for any repair work. It's compromised by insects, especially in a lot of food plants. So insect is an issue. Cold temperature snaps. The temperature, the system designed for this particular building, for example, was not designed for 25 or 30 degree weather, as is evidenced by the temperature in the room that we've dealt with. It wasn't designed for that. So therefore, the system couldn't keep up to provide heat for the atrium areas, for the different rooms, etc. So it wasn't designed with the right thickness or the right capability to ensure that the system functioned efficiently and allowed the system allowed us to believe that we had enough heat in this building in the wintertime, because it's not a normal condition here. You also get freeze-thaw cycles. A lot of times people don't understand that they have to design and install systems for extremes. Texas is a great example of that. Texas is an example where they've had some severe weather and they lost power, severe outages throughout the state, And not just Texas, it's all across the country and in Canada as well. Another issue with insulation is that we have accounting issues. So it's a big picture item. And what's the accounting issue? Oftentimes, accountants look at insulation as a cost. If I install a new chiller in a project, I am going to consider that a piece of equipment. I'm going to depreciate that piece of equipment. A mechanical insulation is the same and should be listed and accounted for in the same manner. So we should consider that an asset on our balance sheets, and as an asset, we can then depreciate that asset as we're financing or budgeting a project, and we don't think about that. That's one of the ways that insulation isn't considered or understood by accountants, engineers, architects, design, stakeholders, and owners. But once again, if the value is that it's an asset, we can then depreciate that asset, just like a chiller. So it's not a cost, it's an asset we've installed, and we should depreciate that yearly, and that includes maintenance for that project. We should be maintaining that insulation. Insulation typically lasts about 30 years. It doesn't need a lot of maintenance normally, unless it's physically compromised. Another example showing the difference on your expense sheets between assets and expenses and compromising, and we don't think about that as owners, stakeholders, engineers. In our budgets, we don't think about these items, and these are things that we should be considering and thinking about for mechanical insulation. Energy audits. Energy audits, there's something called ESCOs, energy service companies. And energy service companies go around and they do energy audits. Many of you may know, many of you may not. An ESCO company will go into a school system, for example, and a school doesn't have any money, and they'll come in and they will do an evaluation of that school. In that audit, they will include things like the electrical cost, the plumbing cost, the heating cost, the cooling cost, the system cost, how long are the lights on in the parking lot, how often do the vending machines run, what are the costs of those motors running in the vending machines. So they're going to do an audit on that. Sometimes they don't think about the mechanical insulation. Very few engineers understand it or do that properly. And that's one thing that we actually do. We go in and we'll do mechanical insulation audits. Typically our paybacks on a mechanical insulation audit is somewhere between 6 months and 2 years. So on almost any project of any size, anywhere in the US or Canada, my payback, my return on investment is going to be between 6 months and 2 years. If that system lasts 30 years, then I'm saving that amount of money for 28, 29 years, simply by that return on that investment. We don't think about that, and that's something that we need to. So energy audits have an exceptional return on investment. The only thing that comes close to an ROI for that mechanical insulation does, it would be steam traps. We also don't change out steam traps, but compared to any other function in a project, ESCOs bring us in to do mechanical insulation energy audits, and we pay for a lot of other retrofits on projects. Windows typically have long paybacks. Like I said, we're typically from 6 months to 2 years, and whether it's a commercial plant, industrial plant, school system, et cetera, with phenomenal paybacks. This is an example of 1 foot of missing insulation on a pipe, just 1 foot. So here we ran some numbers showing you some of the basic costs and the paybacks on the lack of insulation. So if you took out a foot to change out a flange, for example, change out a pump, or a pump's not insulated, or you have a leaking packing nut, whatever the case may be, this is simply showing you the cost, and it's a quick demonstration of how much you're losing on that project by having a foot of missing insulation. So here on this slide showing you this, I believe you can pull this up on the app as well. And an energy appraisal on that 1 foot of an 8-inch pipe shows you the cost per foot. Then think about the cost for if you've got 50 foot missing in a plant, or how much you are missing if you have 1,000 feet, 100 feet, 1,000 feet missing in a plant. You're talking about thousands and tens of thousands and hundreds of thousands of dollars. I did an energy audit at Western Kentucky University. We saved them $1.7 million per year. $1.7 million per year, and that meant that within 1 year's time, we paid for the entire project that we did, and they saved that every year from that point going forward. This is all over the country. We just don't, it's above our ceilings, so we don't see them. Our mechanical insulation systems Our HVAC systems are intentionally hidden from view, so they're above the ceiling, they're behind the walls, they're in the tunnels, they're under the floor, so we don't see them, so they're hidden, so we don't even realize that. That's an issue that goes on all over the country. Again, showing that difference of 1 foot of insulation, the difference in insulated pipe, and showing the BTU savings as well. So if you want to see the numbers, we'll be happy to show this to you. We have a booth over at booth 13 where we have candy as well, but we'll go over that stuff. But we can get more in depth of all these different things, and it's late in the day and we don't want to tie you up if you don't want to see the numbers, but this is an example of the numbers we're talking about. So we can demonstrate this to you in any facility anywhere in the US or Canada. And once again, it's just 1 foot of insulation. And if we insulate that 1 foot of insulation, 1 foot of piping, in this particular facility, in this particular example, you're saving $185 per foot. So for every valve that's missing in this particular example, you're saving $185. And you start looking around in these facilities. I did a recent study you can pull up on our website in Houston, what used to be called Minute Maid Park, which is now called Dyken Field, as well as the Toyota Center. It's a 48-page study, and if you're interested in going through that study, you can go into our website and look that up. It has 48 pages of infrared images. It talks about indoor air quality. The math is there. The accounting is there. The algorithms are there, showing you how it's calculated and how much money is saved, and all the issues that pertain to that, including corrosion under insulation, including mold issues, including ceiling issues, slips, trips, falls. There's a litany of issues and problems with not having your mechanical insulation inspected and having it brought up to speed on at least a yearly basis. Once again, here's the infrared image showing a flange or a valve. The infrared does a great job of showing you the energy loss. Most engineers don't need the infrared. They understand the math, they understand the calculations. But for an energy buyer, for a fuel buyer, for a facility owner, for a facility manager, for a maintenance manager, the image is shown from infrared, do a great job of showing you the energy loss that you're having. Once again, energy supply cost. When we design our buildings, we design them for today's cost of fuel, today's cost of energy. If a system's going to last 30 years, shouldn't we be designing that system for the efficiency and what that cost is going to be in at least 10 years or 5 years down the road? Instead, we think about today, because as an owner, as a general contractor, we hire those people that give us the lowest initial cost. And because they give us the lowest initial cost, it's very easy for them to value engineer out mechanical insulation, even if the cost to the owner might be more than the entire cost of getting rid of it for every year, for the next 30 years. I did an energy audit of a facility that made concrete products, and most of it was outdoor retorts. And when I did the energy appraisal and the value engineering, I gave them an example. They called for 3 inches of insulation on these retorts, or 80 feet long. And the value engineer I gave them was to increase the initial cost, to double it, to double the thickness. And when the engineers saw the cost savings, they were flabbergasted, and we actually did that project by doubling the insulation, and that's how we value engineer it. We doubled the insulation installed on that project because it was worth the savings to them in a year's time. Here's some example of an installation inspection, and any of you that walk through your facilities, you've seen this. You see this all the time. You've seen universities, hospitals, hotels, commercial buildings, schools. But on top, people have walked on the insulation, it's been compromised, it's fallen off. Down the bottom, you see an infrared image showing you some of the energy loss from where we simply remove some insulation. Another example of the reason you need to do an insulation inspection on a project. So a picture to me helps demonstrate, you don't typically go looking for this. You're looking for the water, you're looking for the lights that are out, you're looking for the other things, but these are easy things to notice once you go looking for them and have someone come in that's an expert on mechanical insulation. More examples of insulation. Here you see damaged insulation. So it hasn't fallen off totally, but it's damaged. And the infrared image helps show the energy loss you have from this particular line in this system. These are a whole bunch of reasons why you should insulate. We don't think about things like infection disease risk control. Properly installed insulation systems help control secondary infections, but also infections and viruses spreading from one room to another. We don't talk about improved indoor air quality because of the condensation issues, because of mold and mildew on those issues, on those systems. We don't think about the acoustical issues. Mechanical insulation reduces acoustical noise throughout the facility. Today we install more and more plastic pipes. If you have a house that was built recently and you got plastic drain pipes, you know every time somebody flushes the toilet you hear that pipe and you hear that. If it was insulated, that would help control those acoustics and be one less thing for you to hear or worry about. If you're in this hotel and you're staying near the elevators, you hear the elevators, right? And that's because there's sound issues. Mechanical insulation helps control that. So one of the other things that mechanical insulation does. We also do fire stop, but here's some other elements that we don't think about, but other advantages of mechanical insulation and reasons that you should install mechanical insulation in your facility. So I promise I'll be done on time and maybe a couple minutes before because it's Tuesday and we're getting there. So we'll get you there to go get a drink because you'll be tired of listening to me. So here's a mechanical room, right? This is a typical mechanical room in any facility anywhere in the U.S. And this looks like a great mechanical room, right? It looks clean. It looks like there's a lot of insulation in the mechanical room. It looks like it's well maintained. Everybody does a great job. This looks like a great mechanical room. Is there opportunity here to have savings for you as an owner? Not only does mechanical insulation, if you have a good mechanical insulation system, it helps your budget because you don't have these spikes and fluctuations in your energy cost from those. But here's what it looks like prior to looking for opportunity. And here's the opportunities in that mechanical room. This is the missing insulation in this mechanical room. So most people walking in would say, hey, that mechanical room looked great. If you let me walk in, I can point all these out, identify these on a report, and show you all the money you're losing every day, every hour of every day, by not having these systems properly insulated. So and this is just another typical system. And this is a pretty well-maintained system, by the way, mechanical room. There's a whole lot of them that look a whole lot worse than this. So it's something that we don't think about, we don't talk about it. People think it's a commodity, and it's not. And because they think it's a commodity, they don't think there's value in proper installation and proper maintenance of that system. Here's another savings opportunity. This is just a little heat exchanger, right? A little heat exchanger in a mechanical room. But when you throw the infrared on it, the infrared does a great job of identifying opportunity to help control insulation and help on that project. Typical system lasts about 30 years. Conservatively, we'll say 20. So imagine if you get your payback in 6 months, in a year, even in 2 years, even if it was more than that. Compared to anything else you can do on a facility, you're saving money. And as soon as you install that first piece of insulation, that starts reducing the energy cost for that particular 3-foot section that you install in that insulation. Anything else you put in the facility uses energy, right? You install a chiller, you install lights, you install a pump, a refrigerator, you're using energy. We're the only thing that gives it back to you. And then most of our products have about a 30% recycle rate. So sustainability is huge on that as well. How much money is going out the window by not having a properly installed mechanical insulation system? Questions? Yes.
Thanks so much. Those images are very dramatic. I guess I question if you could go back to the one, you have a very interesting infrared shot. Let's see, if you could go back a little bit, like something like that, okay. So I'm looking over there at this very complicated piece of machinery on the left, and then I'm wondering, is there, I'm assuming, and I may be wrong, that maybe one reason why this isn't getting insulated is because it seems very labor intensive to insulate things that are so complicated in form. Is it possible to spray it so it's not so labor intensive that you'd still get that kind of insulative capacity? Or am I wrong about that? Because I looked at the room that you had before looked like there were, Yeah, exactly. And these are all valves and kind of tiny fixtures and things like this. Tell me, is that what's going on? Is it because it's so labor intensive?
People don't often realize the value. Bottom line, they don't understand the value, and they consider an upfront cost. That's why I talk about the accounting part. On the second, let me go back here, I'm sorry. On this picture, this is typically put on in what's called a skid package. So the general contractor mechanic will buy a skid because they buy that because it is intricate and because it takes more labor to put it together, pull these pieces together. They'll buy a skid, they'll put that skid in a facility, and then it takes more insulation to insulate that skid. And a lot of times those are excluded in mechanical insulation bids. There's going to be 20 different reasons why this particular skid isn't insulated, but I would say that most of the time it's because people don't realize how much energy they're losing, and they don't realize that even though it's labor intensive, if this took them, instead of 6 months to give them a payback, if it took them 2 years, would it still be worth doing? The answer is definitively yes.
So there's no spray, just spray it?
You can spray insulations by and large because the systems are different. So you may have a heating system and a cooling system side by side. You may not need the same thickness, but the problem with sprays is the vapor barriers typically. So vapor barrier means you get condensation under the sprayed on insulation, and when you have that, you end up with corrosion under the insulation. PPG did a lot of that with some tanks I worked on, a particular facility that they had. They used spray insulation, and the maintenance guy, when he's got to cut his budget, well, do I really need to go up there and re-waterproof that again for the second time in the last 5 years? We'll put that off another year. And all it takes is a little bit of moisture infiltration and migration into that system to cause issues. So spray insulations, there are also concerns with off-gassing, et cetera. So there's other issues with sprays, and they often don't hit everything they need to hit. So sprays are not the most economical, and typically they're not the most efficient system for mechanical insulation systems.
If I can add to that, that's a great question. I'm glad you asked that. And this goes back to what we've been saying, is that initially, when people look at a project as that, they evaluate it whether, you guys hear me? Okay. Whether it's worth insulating that or not. You know, the time and the labor, the material versus the benefit. And that's one of the advantages that a mechanical insulation audit can offer. When a mechanical insulation audit is developed, even in this case, it'll be evaluated how much it'll take to insulate that with the contractor, with real numbers. And then we can evaluate how much energy loss is in there. And then you're going to get a document, a scientific engineered document that's going to prove that the cost of the installation is going to outweigh the return on investment. As Jim said many times, anywhere between 6 months and 2 years. Maybe it's even 3 years it has to happen. But before a penny is spent, and we expect anyone to have that unit insulated, you could have an energy audit performed, and you would know how much will it cost to insulate it, and when can you receive and see the return on investment. That's a great question, and I wish more people would ask that question, and we can answer that. Thank you.
Other questions? Yes.
So the slide she was pointing to with all the circles is really compelling. That's a great slide. This feels like there could be kind of a layup down the road for you guys to be able to leverage some sort of a robotic tool to help with this. Are y'all seeing much in the way of innovation in this space, or is it just that overlooked that it's not really getting
so much
any attention?
innovation, and the reason we're here
Yeah.
is we're trying to educate the stakeholders of the fact that mechanical insulation is often considered a commodity. The group that was here just before us speaking talked about multi-skill sets and sharing across skill sets. And when you have a scaffold builder and install insulation, you have gaps in insulation, you don't see the energy loss unless you have an infrared camera showing that energy loss. You also don't see the moisture migration, you don't see the noise issues you have, you don't see all those issues. So we're here to help educate about that very thing. We also do other shows for the same reason. Are we seeing a lot of it in the industry? We're seeing more and more of it from the ESCOs, the energy service companies, because those engineers are realizing the value. We spoke at the Association of Energy Engineers. So are we seeing enough of it? No. Are we seeing a little bit more? Yes. There's also a lot of people out there not understanding how to do it right, and that's an issue. So people will come through and not properly perform an energy audit or a mechanical insulation energy audit, and they're not using good systems. We use a system that's based on a Department of Energy developed system that's been in existence for over 50 years for the algorithms with case studies and follow-ups to ensure it's conservative, and these are simple paybacks. When we say 6 months to 2 years, we're about simple paybacks. Most energy audits don't include simple paybacks. They include complex equations on what's the cost of a new impeller, what's the cost of a new chiller. Ours are simple, so the paybacks are very conservative, and 6 months to 2 years is a conservative number. Does that answer your question?
It does. No, it's helpful. Do you guys see, and it's a much smaller scale, but it seems like at the residential level, there's probably enormous amounts of energy loss.
There's enormous
across...
amounts of energy done in residential. We're funded by 2 groups that don't do residential. So we don't really attack the residential market, but the same value holds up in residential. This infrared camera we have in here, I can tell you that if you're married, you don't take this home. Because when you get home and the spouse takes this camera out and sees your windows leaking like they've been complaining about for years that you haven't fixed, or that sealant that wasn't installed, or that moisture infiltration, as you can detect insects with this, all kinds of issues. It causes a lot of issues when people realize what's really going on. Very quickly, I did one in a mechanical room. The engineer said, we have an issue here. This woman was always complaining. We think it's her age and some other things. I went in and did an infrared image. She was sitting above a mechanical room, and the floor was literally 110 degrees. So every day, she was in an environment that wasn't good for her, and be careful what you ask for, because sometimes it'll bite you. So, other questions? Does that answer? Other questions? All right, yes?
Just one more. So, so the process that I'm used to, I guess from, I'm an owner and I'm going to operate the plant, industrial plant, but I also want to give the designers a specification at the beginning, and I want to say this is how I want you to design the system and the amount of space, the amount of insulation that we might be putting on this piping. So this can all get designed in so that when the insulator comes out, I'm going to hand them a 50 or 60 or 70 page, very complicated spec to talk about thickness, to talk about moisture barriers, to talk about how you do joints and all of that stuff. Most of those specifications that I have seen were created many, many years ago. I guess the question is, do you guys do an audit? So a lot of this is, to me, is after the fact. Somebody installed this, mechanical contractor had to get out of the way, looks like a lot's done, but you still have a whole lot of heat leak here, or a lot of loss of energy.
An installation expert can go in and run the numbers based on what you want, your parameters. So you give me your expected fuel cost, whether it's today's or where you expect it to be in 5 years. You give me those costs. You give me the wind speed, so I need some things. How efficient is your system going to be? Is it going to be 75, 85, 95% efficient? What are the efficiencies going to be? What are you concerned about? Are you concerned about a fork truck running into that mechanical installation? So what type of installation are we going to install? So some have better physical resistance than others. So we're going to go into those things. And then we're going to look into the size of the hangars that the hangars need to be, what type of system we're using. Victolics, where you have huge amounts of mass that end up using more energy or losing more energy. So yes, you can do it on the front end. Not enough people are, if that answers your question. Other questions? All right, as far as I know, the drinks are free, so go have at it. Thank you very much. We appreciate you. Thank you for coming.